All right, hello Algebra 1B students, this is Mr. Widmeyer. I'm coming to you pre-recorded in order to help you go over the quiz review in preparation for your Systems of Equations quiz. All right, now I'm going to go relatively quickly, but if you need to listen to anything, again, you can always rewind the video, rewatch it, okay, and get some extra help that way, okay. So yeah, let's get started here. If your classroom also has an SSL, please feel free to ask that student for some help too if you need to. Okay, so what we're going to be looking at right here is the quiz review in preparation for the quiz that you'll be taking on systems just in a little bit. All right, so we'll go ahead and go through these here. Now, the directions here for these first couple problems say graph the following systems of equations to determine if they have one solution, infinite solutions, or no solutions. Remember that not every system has a solution to it, so we want to be comfortable with graphing and stuff like that and determining, what kind of different options we have. All right, so let's take a look here at number one. All right, now, when I look at number one, the very first thing I notice here is that we have one equation in slope-intercept form already, right? Y equals mx plus b. All right, so in this case, for this one, our m is a -3, or as a fraction, -3/1. The b for this equation is -2. Don't forget that minus sign in front there. That's part of the b. Okay, I'll zoom in some more on that. There we go. The second equation, is it in a form that we can graph? And the answer is no. It's in something called standard form, right? We need to get it in slope-intercept form. Notice slope-intercept form, right? It's solved for y. We want to get the y by itself. The same thing is true right here. If we solve this bottom equation for y, we will get the equation in slope-intercept form. It'll be easier to graph. So to do that, we're going to subtract 6x from both sides first. Cancel those out. We're left with a 2y on this side. -4 minus 6x, those are not like terms, right? This has an x, this does not, and so we'll just rewrite -4 minus 6x. We have one more thing to get rid of here. That's with the y. We wanted to get rid of the 2, so we're going to divide by 2. So divide everything over here by 2. We end up with y equals -2 minus 3x. So now when we look here, excuse me, we have a slope of -3 and a y-intercept of -2. Okay? Now, let's go ahead and graph these. The first line, y-intercept, will start at -2. And the slope is -3/1. So that means from the -2, we're going to do a rise of -3, so down 3, and then right 1, a +1 slope, or a +1 run. Okay? We can't go any further, but we can go backwards. So instead of going down 1, right 3, we can also go, instead of going down 3, right 1, we can also go up 3, left 1. Up 3, left 1. Okay, and there's our line. And we can go ahead and draw that here. I'm going to try and just freehand it. All right, not too shabby there. Okay. Now let's go ahead and graph our second line here. The second line has a y-intercept of -2 and has a slope of -3/1. So down 1, 2, 3, right 1. There's our point, right? Can't go any further. We'll go backwards. Up 3, left 1. Up 3, left 1, and you can see we end up with the exact same line as the first one. Okay, since a solution to a system is where our two lines intersect, to a solution to a linear system is where the lines intersect. Well, these lines intersect everywhere, so the answer here is infinite solutions. Okay, because it's the exact same line. You may have noticed that just by looking at the pieces of information right there, right? The slope and the y-intercept are the same as the slope and the y-intercept there, so they're going to be the same line. You may have noticed that. You still want to do graph it, though, because the directions did say to graph the system, okay? But at least we can kind of confirm that, yes, they are infinitely many. All right, on to number 2. We have this line, x equals -3. Now, you'll notice this is not in slope-intercept form here, but there's also no y to solve for. How do we graph the line x equals -3? Well, let's think about where does x equal -3 in our coordinate plane down here. And here's the x-axis. There's where x equals -3. But how do you create a line from a single point? Well, every point above this, every point below this will also, all these points along here have an x coordinate of -3. And so that creates our line. All these points that have an x-coordinate of -3. Okay? The second equation is also already in slope-intercept form, so we can go ahead and graph that. Y-intercept is 1. Okay, the slope is -2/3. So from that y-intercept of 1, we go down to right 3. Down to right 3. Or up to left 3. Up to left 3. And connect the dots. Oops. Oh boy. All right, you get the idea, right? What's most important, this is a little messy, but what's most important is that we find that point of intersection. The point of intersection has coordinates of -3, 3, and so that is our solution. One solution at -3, 3. Okay? Let's go to the last one here now, and we can see that both of these are in slope-intercept form. The m here is 2, or as a fraction, 2/1. The y-intercept is -1. Here, the slope is 2, or as a fraction, 2/1, and the y-intercept is 3. Okay. Again, some of you may already be able to tell what kind of answer we're going to have here based on the information that we've got. But let's go ahead and graph it and see what happens. Okay, y-intercept is -1. Slope is 2/1, so it means we're going to go up to right 1, up to right 1, up to right 1, or down 2 and left 1, down 2 and left 1. And connect those dots. Okay, for the second equation, the y-intercept is 3, and we'll go up to right 1, or down to left 1, down to left 1, down to left 1, down to left 1, and we'll connect those dots. Okay, now, it doesn't look like these lines are going to intersect, all right? And maybe they might intersect somewhere, outside of our graph here, but we can actually convince ourselves that these two lines will never intersect. You can see here that their slopes are exactly the same. When two lines have the same slope but different y-intercept, that means these two lines are parallel. And so they're never going to intersect, which means we will have no solution. Okay? So, 1, 2, 3 questions there, and each of them have the different kind of solution we can have here. First one had infinite, next one had one solution, and the next one had no solution. Infinite when you have the same line, exact same line being graphed twice. One solution where you have two lines, and that's where they intersect. And then no solution when you have no intersection at all. Okay? All right, that's graphing. Moving on to substitution now. Substitution, remember the goal here is to plug one equation into the other. Okay? Now, in this particular situation for number 4, you can see that we have y equals x minus 1. So wherever I have a y down here, which is right here, I can replace this y with this x minus 1. So x minus 1 is going to go right in here for the y. So we'll have 2x minus, and then parentheses, x minus 1 equals -1. Okay? Now we have a minus sign in front of parentheses, so it gets distributed. It's really like a -1, you can think of it like. So -1 times x, -1 times -1. We get 2x minus 1x plus 1 equals -1. And now combine like terms. 2x minus 1x is 1x. Okay? Subtract 1 from both sides. We get x equals -2, or 1x equals -2, which is the same thing as just x equals -2. Okay? We're not done though. Yes, we've solved for x, but we still have to solve for y, the matching y coordinate. So we'll take this -2x value, we'll plug it in for the x right here. Y equals -2 minus 1. Again, use parentheses when you substitute in. -2 minus 1, -3. So we have y equals -3. So our final answer is -2, -3. That's our solution there. Okay? Let's look at number 5. Now number 5, you look at that and you're like, oh, Mr. Whitmire, both of these are in slope-intercept form. Let's just graph them to find the solution. Okay? And that would be a good way to go about doing this, but our directions specified substitution. So while you might be able to get some points just because you can get the right answer, you need to use substitution if you want to get full credit there, because that's what we're being asked to do. So we're going to do substitution. Now, you'll look here and you'll see y is equal to x plus 2. We also have y is equal to 2x minus 6. So you can see both of these equations are solved for y. Y is equal to this, but y is also equal to this. Well, if y is equal to this and y is equal to this, what must be true about x plus 2 and 2x minus 6? They're both equal to y, the same y, right? And so they actually, we can say they equal one another. Or you can think about it like this. We're going to take this x plus 2 and substitute it in for the y right there. So we'll have x plus 2 equals 2x minus 6. Okay? We want to get the x's together on the same side. Okay? So they're on different sides. So I'm going to subtract x from both sides. Okay? Leaving me with a 2 there. 2x, take away an x, is just 1x, or x. Bring down that minus 6. Now we'll add 6 to both sides. And we get x equals 8. We're not done yet, though, right? Because we have the x-coordinate, we need the y-coordinate. So I'll use the top equation again. You can use the bottom or the top equation. It doesn't matter. So I'll plug the 8 in for the x. 8 plus 2, 10. So now we're finished. 8, 10 is our solution. Okay? Remember that you could have graphed these, okay, especially if you wanted to use your graphing calculator. But really, we should be able to do. We should be able to follow the directions there when it says that. We should follow the directions because that's what we're being asked to do. All right, turn the paper over. All right, 2 more questions here for us. Elimination. 2 elimination questions. And so again, both of these are pretty nicely set up for elimination, and we're going to use then elimination to help us solve these. Let's take a look at this first one. Okay. Now remember, for elimination, our goal is to add or I really just like to add, but some teachers may also say subtract. Add or subtract the 2 equations together to make them cancel out, or to make some variables cancel out. So if I look right here, if I were to try and add these equations together right now, would any of my variables eliminate or cancel out? The answer is yes. 3x and negative 3x, they would exactly cancel. Negative 2y and positive 2y would also exactly cancel. So let's see what happens here. Let's add these 2 equations together. 3x and negative 3x cancels, leaving me with a 0. Negative 2y plus 2y is also going to cancel, leaving me with 0. And the 5 and negative 10 add together to make negative 5. And now we end up with this strange statement. 0 equals negative 5. Does 0 ever equal negative 5? And hopefully you're either thinking in your head or saying out loud, no, okay? And you're right. 0 never equals negative 5. So then what are we supposed to say here? Well, we started with something that resulted in a false statement. So the thing that we started with must also be false, okay? We start with a false assumption. We start with an assumption here. We arrive at a false conclusion, so we're going to say that this also is false. In other words, no solution. We arrived at something that is never true. Okay? Now, number 7. You can just leave no solution there. You can put none down here. By the way, sorry, I forgot. I should have said that too. Something like that. All right, number 7. Now, same thing. We're looking to eliminate. If I look at these right away, all right, I can see here that if I try and add these together, 3 plus 4 is not going to cancel. Negative 4y plus 2y will also not cancel. So we need to multiply by something to the top and or the bottom, okay, in order to make these things cancel. Okay, now you have some choice here. One way you can always ensure that you get a variable to cancel is just to pick a variable that you want to eliminate. So for example here, you could say, let's decide that we want to eliminate the x's. Okay, to eliminate the x's, I'm going to multiply one equation, the top one here, by the bottom one's number, by the bottom one's coefficient. And I'll multiply the bottom equation by the top one's equation and make that the opposite. Okay, and you'll see why here. So by doing 4 times 3, I'll get a positive 12, and then a negative 3 times 4, I'll get a negative 12. See what I'm getting at here? We'll get these to cancel out. So that gives me a 12x, and 4 times negative 4 is negative 16y. 4 times 21 is going to give me an 84. Negative 3 times 4 will be a negative 12x. Negative 3 times 2 will be a negative 6y. And negative 3 times 6 will give me a negative 18. You can see we created opposites here. I can add these 2 together. They cancel. The 12x and the negative 12x. Negative 16 and plus negative 6 gives me negative 22. 84 and minus 18 plus negative 18 gives me 66. Divide both sides by negative 22. We get y equals negative 3. We're not done yet, right? Once you get y equals negative 3, then we'll plug that in, either to the top equation here, the bottom equation here, or one of these 2 equations. I'm going to just use the first one here. 3 times x minus 4 times negative 3 equals 21. Okay, negative 4 times negative 3 is positive 12. Subtract 12 from both sides. We get 3x equals 9. Divide both sides by 3. X equals 3. And so we get the solution 3, negative 3. Now, that's one way to do this. Alternatively, though, we could have tried to eliminate the y's. Again, we eliminated the x's, but we also could have eliminated the y's. If you look here, it actually is going to be easier to do that. I can multiply 2 by a positive 2, and that would make it positive 4 here, which would exactly cancel out that negative 4. So strategically, it would probably be better to multiply this bottom equation by a positive 2 to make this positive 2y become a positive 4y. Let me show you what I mean. So I'll rewrite the original equations, the systems, I should say. Okay, the bottom equation, I can see if I just multiply this 2 by a positive 2, it'll be 4, which will cancel out with that negative 4. And so I can get away with just multiplying one of the equations here, not both. So this one can stay the same. This one will become 8x plus 4y equals 12. Okay. Now we can add these two equations together. The 4's will cancel. 3 and 8 make 11x. 21 and 12 make 33. Divide both sides by 11. You get x equals 3. And then, of course, you can plug that 3 into one of these two equations here. I'll just pick the top one. 3 times 3 is 9. Subtract 9 on both sides. I'm going to run out of space, so I'll go up here. Negative 4y equals 16. Oops, 12. Sorry. Math. 21 minus 9 is 12. Divide both sides by negative 4. And lo and behold, you get y equals negative 3, the exact same answer we got here, doing it a different way. Okay? So you have some choice when it comes to elimination. All right? You can try and be strategic and efficient by noticing here that, oh, if I just multiply the 2 by a positive 2, I'll be able to cancel out with a negative 4. Or you can just pick a variable at random. Here in this case, I chose to eliminate the x's. I'm going to multiply the top one by 4, the bottom one by a negative 3. Again, I got the 3 from here, but I want to make a negative 3, so that way I have a positive 12 here and a negative 12 there, and they'll cancel. Either way, you can see you get the same answer. Okay? And so that concludes the majority of the portion of the quiz that you will need to be concerned with. Now, if you have extra time and you want to get a little bit of extra practice or a look ahead at like some things that we should be able to do, I will also talk about the other questions here as well. Okay? Now again, at this point, this is no longer stuff that you'll be have to worry about for the quiz, but I'm going to go ahead and go through this anyway, just in case you want to learn a little bit of extra. All right? If you don't want to learn extra, feel free to go back and rewind this video and watch some of the other stuff that you maybe wanted to see again. Okay, but again, I'll just go through this stuff just because it's here. Okay, so number 8 here, we got some word problems. Again, these will not be on the quiz, but they will be needed for the future. So it's not helpful. It's not a problem to see this now too. Okay, so number 8, there were 342 tickets sold for a football game. Students cost $5 and adult tickets cost $8. The receipts for the game totaled $2,070. How many student tickets did they sell? How many adult tickets did they sell? Right? And so the number of tickets, student tickets, and the number of adult tickets, that's our variables. So we'll say A is the number of adult tickets sold, because we don't know that number. S is the number of student tickets sold. And again, we don't know that number. Okay? Write to equations. So we'll write an equation that represents the total number of tickets equation. Okay? So how many total tickets were sold? Well, we know there was a total sold of 342. So that means if you take all the adult tickets and you add all the student tickets together, it should add up to 342. At the same time, we also have a cost associated here too. Okay, every adult ticket is $8, so they make $8 times the number of adult tickets. Plus, they make $5 for every student ticket. How much total money they make? $2,070. Okay, just like that. You'll see here that we have a system of equations, right? A plus S equals 342, 8A plus 5S equals 2070. And you can choose how you want to solve this, okay? You can use elimination, All right, it's not too shabby for an elimination. You can also use substitution. I'm going to pick, let's just do elimination here. So a plus s equals 342. 8a plus 5s equals 2070. And to get I'll just choose to eliminate the a's here. To get opposites with that, I'll need to multiply the top by a negative 8. Right? I have a positive 8a here, so I want this to be negative 8a. So that will change that to negative 8a minus 8s equals negative 8 times 342, which is negative 2,736. We have now a positive 8a, positive 5s, 2070. Add them together. 8a's cancel. Negative 8 and 8a cancels. We have a negative 3s when I do negative 8 plus 5, and then add those two numbers together, and we get negative 666. That's not a nice number. Oh well. Divide both sides by negative 3 to get the s by itself, and we get 222 tickets. Okay, but we're not done because we also want to figure out the number of adult tickets that were sold too. So let's go ahead and plug it back into this very first equation here. Super simple to do. Okay, subtract the 222 from both sides, and that is 120, and that's the number of adult tickets, and that's the number of students. Okay. Voila. You can also use substitution. All right, moving on. Andrew would like to purchase an online movie viewing subscription. He has found two sites which offer low prices. Movies Now charges a fee of $1.50 per movie. Flicks on Demand charges a one-time registration fee of $5, but only charges $1 per movie. Okay, what units will be on the x-axis? That's going to be the number of movies. And will be on the y-axis, it's going to be the cost. So number of movies cost. Write an equation to represent the cost of subscribing to Movies Now. So Movies Now just charges a $1.50 fee per movie. So it will be, let's say like C equals 1.5 times M. Number of movies times $1.50 equals the cost. So what's up?
I was just wondering if you could send Sydney and I instead.
Yep, I put you in.
Oh, thank you.
Yep, no problem. All right, and then Flicks on Demand, all right, that is a different one. One-time fee of $5, so its cost would be $5 plus then $1 per movie, like that. Okay? So there's its fee. Now we're going to graph each and label the axes. Well, I already took care of labeling the axes there. So let's graph this first one. 1.5 m. So this is in slope-intercept form, right? Think about that c is like the y and the m is like the x. So that's 1.5 is our slope. 1.5 as a fraction is the same thing as 3 over 2. So we just have a y-intercept of 0 here, slope of 3/2. So we'll start at 0. Okay? And we've got to be careful here because when I count up 1 on the y-axis, I'm actually counting by 2's here. So be careful. And on the x-axis, I'm counting by 1's. So if I want to go up by 3 for my slope, I have to count up to halfway here and then over 1. And up another 3 will get me to 6 and then over 1. Up another 3 will get me to 9 and over 1. Up another 3 will get me to 12 and over 1. Okay? And you can actually kind of see you're actually going up 3 boxes and over 2. So we can do it that way too. That kind of worked out nicely. Okay, and connect the dots there. Keep going. Okay, so this is Movies Now. And then finally, Flicks on Demand. Flicks on Demand will be 5 plus 1m. So let's see here. Here's 5. Y-intercept is 5, right? And then 1m is the slope. So up 1 will get me to 6. Over 1 will get me to here. Up 1 gets me to 7. Over 1 gets me to here. Up 1 gets me to 8. Over 1 gets me to here. Up 1 gets me to there. Over 1 gets me to there. And so it's up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Remember, to go up 1 for the y-axis, you're going up a half. Like that. Okay? Now, how many movies will Andrew need to watch in order to spend the same amount for each service? 0 and up 3, right mark. Up 3, right mark. Oh, right 2. That's what my issue was. This is wrong. It's supposed to be up 3 over 2. I went up 3, but only over 1. So that's where the point should be. So, okay, so forget this line. That was my problem. Sorry, folks. Up 3, right 2. Like that. Up 3, right 2. Up 3, right 2. Up 3, right 2. Up 3, right 2. Okay, that was the issue. Okay, that is Movies Now right there. This one is Flicks on Demand. So I counted my slope incorrectly. You can see it's very hard, even for a math teacher, to get that right on the first shot. So again, ignore this line. I did the wrong slope there. To use that slope of 3/2, you start here at the y-intercept of 0. You go up 3, so 1, 2, 3, and then right 2, so 1, 2 right there. Now it's much easier to see our point of intersection, though. So how many movies will Andrew need to watch in order to spend the same amount for either service? 10 movies. That's where they're the same cost. How much money will Andrew have spent if the cost is the same for both services? So at 10, he will have spent, well, right here, it's halfway between 16 and 14, so it's going to be $15. Okay, so there it is, folks. Again, these kind of word problems will not be on the quiz, but we will be using them later, so if you looked at this, that was good for you to do that. If you want, again, go back and take a look at the old stuff earlier, the problems we were just solving by graphing, substitution, elimination, and that'll be helpful for your quiz. Okay, so again, if you need to rewind the video, go back, look at these old questions that we talked about right here. Okay, good luck on your quiz today, and we'll see you Thursday.